Hey guys, with this being the newest stuff that we've done, I wanted to make sure that there was a video that went along with this. So, integration by substitution, the first step is to figure out what you're going to call u. And that's still true if we're doing the definite integral. So, u in this problem is going to be equal to the square root of x. Du is equal to 1 over 2 square roots of x. So now we can rewrite this integral in terms of u. So we have the cosine of u du. But when we wrote in du, the du in over here has a 1/2. So we're going to have to multiply this integral by 2. We also have to change our limits of integration. Our lower limit of integration was 1. U is equal to the square root of x. So the square root of 1, our new lower limit of integration is 1. U is equal to the upper limit of integration, square root, so the square root of 4 is 2. When we go to take the integral, we're going to multiply it by 2. The antiderivative of the antiderivative of cosine is sine. And now, because we're doing the definite integral, we don't have to worry about the constant of integration. Now let's plug in our limits. 2 times the sine of u, but u is now, so 2 times the sine of 2 minus 2 times the sine of 1. And now, because we don't know the sine of 2 or the sine of 1, they're not values that we had to memorize back in pre-calc, we're done. We can leave our answer as that. Okay, so again, what are we going to call u? U is equal to 5x plus 6. Du is equal to 5. So when we rewrite this as a integral in terms of u, we have u to the 1/2, because I'm going to need to add 1 to it, so I'm going to write it as 1/2 rather than the square root, du. But if we look at du, du is equal to 5, so we have to multiply by 1/5. Okay, now let's change our limits of integration. Our lower limit of integration was -1. U is equal to 5 times -1 plus 6. So our new lower limit of integration is +1. U is equal to 5 times 2 plus 6. So our upper limit of integration is 16. Now I think that we're getting pretty good at taking the antiderivative of u to the 1/2. But when we add 1 to this, and I really think it's helpful to add 1, so when we write 1 as 2 over 2, we can see that we have u to the 3/2, and then if we divide by 3/2, that's the same as multiplying by 2/3. And we're doing this from 1 to 16. I'm going to clean this up just a little bit and say that this is 2u to the 3/2 over 15 from 1 to 16. So now we can plug in our limits. 2 times 16 to the 3/2 over 15 minus 2 times 1 to the 3/2 over 15. Now when we're raising something to a fractional exponent, we have to make a decision on whether or not we want to take the power or the root first. I think it's going to be helpful to take 16 to the 1/2 first, because 16 to the 1/2 is 4, and then raise that to the third. So we have 2 times 64 over 15 minus 2 over 15, because 1 to the 3 halves is just 1. And just as a little kind of a side note, if we thought of 16 to the 3 halves as 16 to the 1 half to the third, that would be 4 to the third, which is 64. So then we get 2 times 64 is 128 over 15 minus 2 over 15, so we get 126 over 15. Okay, as always, let's pick a u. U is equal to x squared plus 1 du is equal to 2x. Let's rewrite this as an integral in terms of u. So we have u to the negative 3 du, but du was 2x, so we have to multiply by a half. Changing our limits of integration, u is equal to 0 squared plus 1. Our lower limit of integration is going to be 1. And u is equal to 1 squared plus 1, which is 2. So this is equal to, get out of there, 1/2 times. Now, we do have a little bit of a problem adding 1 to negative exponents. So I think it is very helpful to just add that 1 in there. So negative 3 plus 1 is u to the negative 2. And we have to divide by that new exponent. And we're taking this from 1 to 2. Let's rewrite that as, 2 times 2 is 4. And I like to write my negatives in the numerator. So we'll have 1 over 4. And we'll bring that negative exponent down. So 1 over 4u squared from 1 to 2. Now we can plug these values in. So we have negative 1 over 4 times 2 squared minus negative 1 over 4 times 1 squared. This is equal to negative 1 over 2 squared is 4 times 4 is 16 minus negative 1 over 4, so really plus 1/4. Let's get a common denominator. 4 over 4. And for our final answer, we have negative 1 plus 4 is 3 over 16. All right, last one. Okay, so what are we going to call u? U is equal to x plus 2. du is equal to 1. That's nice because we don't have to worry about multiplying by any constant. Let's rewrite this as an integral in terms of u. And we get 1 over u du. Now we don't have to multiply this integral by anything because du was just 1. But we do have to change the limits of integration. And I think that they were made to look more difficult than they are. And when we go to do our u substitution, it makes it easier. So u is equal to negative 1 plus 2. So our lower limit of integration is 1. And our upper limit of integration, e minus 2 plus 2. So we just get e. So our upper limit of integration is e. The antiderivative of 1 over u is the natural log of the absolute value of u from 1 to e. And again, we don't have to worry about the plus c when we do the definite integral because we'd be adding it to the upper limit and then subtracting it when we did the lower limit, so the plus c's will end up canceling out when we do the definite integral. So now we can plug in our limits of integration. We get the natural log of e minus the natural log of 1. The natural log of e is 1. The natural log of 1 is 0. So we get 1. Alright, let me know if you guys have any questions. You do have the solutions to the first 7 problems, but let me know if you have any questions on those too.